Okay.
Well,
so Gerardo Canedo has been so kind to join us and share his expertise. He's a computer security specialist and computer engineer with more than 15 years of experience in IT consultancy. He works for a consulting company called Genexus Consulting as the chief security manager and software architect. And if you want to take over, Gerardo, I'm going to mute myself and let you take over.
Okay, well, good afternoon to everyone. Sergio said, my name is Gerardo. I work for Genexus Consulting, secure as a secure guy and software architect. And today I'm going to present you this presentation, which is called Inside the Mind of a Hacker. Nowadays, we are facing with all the digital transformation that has been around for quite a few now, and the rising of the COVID, the pandemic, and all the stuff that we have been through. We have seen that pretty much every business has a face on the internet, okay, and that is the normal way to interact with a company nowadays. Something that's very good for working with our customers, with our partners, with our providers. But also when we put something on the internet, it's in a heartbeat, bad people, threat actors start rising and knocking our doors to see what they can do. Sometimes something that we have seen is that there's a lot of rush for software to be online in a very fast pace. And most of the time, what we have seen is that software may not be prepared for being exposed to the internet because of security issues. Sometimes that issues can lead all the organization to a very bad situation. Okay. In the 2020, 43% of the attacks that has been recorded were to web application. One of the things that I think that's the reason is that every company has a web application, every company has APIs. We are doing a lot of software, and that software is web-based. So we have seen the past few months attacks to all Microsoft Exchange servers. We will always have emails and remote desktop, stuff like that. That's also something that an attacker could use. But the rise of the attacks to web applications is because we are doing a lot of web applications, and a lot of them, they are not securized, they are not tested, and attackers know that software has vulnerability, and the build software, the in-house build software, may have more vulnerabilities than some other software that is just commercial software. So today what I'm going to present you, my apologize, my co-working is upsetting me a little. Well, today what I'm going to present you is how a hacker thinks. Okay, so before starting, let's try to define what is a hacker. Okay, one definition for being a hacker is the gaining of unauthorized access to data in a system or computer. And it has some kind of bad. The word hacker sometimes it means something really bad, or a bad person, something like that. It's got nothing to do with that. But for this presentation, we are going to stick with the definition that the hacker is somebody that's trying to do something to our system without proper authorization. okay? It's just the definition that I'm going to use. Of course, there's a lot of hackers that don't do that. They are white hackers and they do other things. But in this particular time, I'm going to ask you to think in that definition. Okay. So, are all the hackers the same? Quickly thinking, I can tell you, you may believe that they are type of hackers. Not every hacker is the same. Okay. There are scripty kids that are amateur hackers, that they use tools and scripts made by other people without knowing exactly what those tools do. Okay. Most of the time, what they do is to watch a video in YouTube or Twitch or whatever platform they want. They log into Discord and they seek for just something for fun sometimes, okay, or to learn something new. And what they do is they reproduce the steps of somebody else without probably knowing what they are doing. Okay, they want to hack Instagram, for instance. They don't know how. Just hack for Instagram. They look for a video and they try to do that. Okay, or they have a tool. They get the tool. They look for a video, for a website, for some information, very easy, and they use that information to attack some other site. Okay, those are scripty kids. Then we have opportunistic attackers or hackers. Okay, when we are talking about an opportunistic, it's somebody that has seen something strange, or they know a vulnerability, they know a particular exploit, okay? And what they do is they just try to execute that exploit, execute that attack in a lot of places, okay? Your system is just an IP on the internet. To be attacked, the attacker may not know nothing about you, not even what your companies do. Okay, they try to execute an attack, and if they are successful with an attack, they see what they can do. For instance, a ransomware, they get a database, they get all the data they can, and after getting the data or pivoting using your infrastructure for attacking somebody else, stuff like that, they see what's the next plan. They don't see you as their target. You are just the first target or the next target. Okay, they are opportunistic. Then what we have seen is motivated attackers. Motivated attackers are attackers with a special interest in the target. Okay, they decide to attack this company, that site, or whatever they want to attack. In that case, what they do is they analyze that specific target, they gather information, they dedicate time for that specific target, they learn how you work, what's the company about, the people that work there, the infrastructure, they do a lot of research, and they use a methodology for doing that, okay? And they are, most of the time, they have a lot of patience, okay? And seeing what you got, they plan the attack. Okay, so they have a lot of knowledge about a lot of things. On the other hand, the opportunistic may know a lot of one thing. Okay, but the motivated attacker may have advanced knowledge to see which is your weak point. Where is the best way to attack that organization, that target, or whatever they are attacking. And last but not least, we have state or nation sponsored attackers. Okay, in this case, this is cyber war, and they work for a government, and they may be attacking another government. And in the everything that goes into in the place, they attack it, and you know it's a different game. Okay, so for the presentation of today, I'm going to try to explain you what a scripted kill, the most simple attacker, can do with information that can be seen on the internet with paying nothing, just for free, and an attacker can use to harm your organization if they are lucky enough, or if they are good enough. Most of the time, what we have seen with scripted kills that they are young people, and something that the teenagers and young people has more in these times with COVID more is time. So they can spend hours and hours just executing tools to see what went wrong, what happens, and sometimes that executions do a lot of harm. Okay, why that happens? I love this chart from Courage Melon. It's quite old. Okay, it's been around for a lot of time, but it tells something that is we know for seeing the reality that it's getting every time we have seen that people with less knowledge it's doing more damage. Why is that? That's what the chart said. This is the impact, the sophistication of the attack, and this is the knowledge. Okay. This is because nowadays we can look for any kind of software in the internet, and we can query for exploits, we can query for information. All the information is really accessible. Okay, and the only thing that you need is a computer, internet, and time, and dedication. Okay? And sometimes with an exploit, when an exploit came out, or when a new technique arises, you can find tools that can be used to attack organizations, and maybe those organizations doesn't know about this specific attack or this vulnerability of whatever. So sometimes a scripted kill can get a lot of damage into an organization, and this is being seen more and more. And this chart explains exactly that. It was true in 2010. It's even more true now, 2021. Okay, so what's the methodology an attacker use? Is this first the attacker? This methodology came from the NIST and NIST. Is the same methodology that we use for a vulnerability assessment or an ethical hacking. Okay, and we have seen that attackers use pretty much the same methodology, but most of the time they don't do the reporting. Okay, you don't get the report. You get the service, the attack, but not the report. That's what I define an attacker, not a hacker. That's the attacker. And the first thing is to plan the attack, to understand the organization, to see what they do, who are the providers, the information public on LinkedIn, on public websites or social networks. Then they go to a discovery phase. They start to see all the endpoints, all the information assets that they are exposed to the internet, to understand if those which is the asset that seems to be more vulnerable. And after that, an attack is conducted over some of more than one of those endpoints. And it could happen two things. One thing is nothing happened, there was a control, everything works perfect, cool. Or on the other hand, what could happen is that the attacker could be successful and gather a new attack surface, which means that they had access to something at the very beginning. After the attack, they get a little more access, maybe remote code execution on a server, or another web page, or a username of whatever. And with that new information, the attacker can start discovering which is the next step, and to attack the organization a little further. And iterating over this cycle, an attacker can get really deep into your organization. This is the model that the OWASP, Open Web Application Security Project, which is a non-profit organization for security, for application security. This is how OWASP model an attack. I'm not going to talk about this right now. I'm going to talk about this a little later with a practical example. Okay, but now let's get into the mind of a hacker. Okay, when a hacker sees this, when you see this, what do you think? Feel free to speak. We are a few people. If you are okay.
Login page?
Yeah, it's a login page. What do you think when you see this? Okay, I can go on. I don't have a username, a password.
Like an account to a website or like a social media account?
Yeah, like for a website. In particular to this website here, okay? So I have here and here, I believe, try user, password, okay. The login is working. I don't know a username and a password. I can't go any further. This is why it's been done. This login has been done. Okay, so that's the way that we developers or we think. Okay, if the username and the password are right, let it get in. Otherwise, just drop it. Okay, but an attacker, when sees something like this, start thinking, how can be bypassed, or how can this be attacked? Okay, and the first thing that comes to the mind of an attacker when sees a login is to do some kind of attack of trying a lot of passwords. As we are thinking as a scripty kid, I'm going to use tools that a scripty kid can use. Okay, so I'm going to use a lot of information that is free on the internet. An advanced attacker, a motivated attacker may do something a little different, but let me explain you a little bit the tools that we are going to use. I'm going to use a Linux distribution called Kali Linux, which is a distribution for doing attacks, for pen testing. Okay, I'm going to use a software called Hydra. Hydra, what it does is, if you put in Hydra a list of passwords and a list of usernames, Hydra will try each and every user password combination. And if one of those passwords is correct, we are going to know it. So we are going to do a brute force attack with a few clicks. Okay, and also for this particular example, I'm going to use one of the most well-known password dictionaries in the software security industry called RockU. This is an old password list, and it's incredibly useful. It works a lot of times. There's a lot of word lists, and every time that somebody publishes a database on the internet with usernames and passwords, a new word list is created. Okay, I'm going to use RockU, but there's a lot of word lists like SegList, and if you are doing a motivated attack against a specific target, there's a lot of techniques to create a custom word list for those specific targets. Okay, so what I'm going to do now, I'm going to use this page to attack it. You may be familiar with the developers tools from pretty much every browser nowadays. I use this a lot, in particular the network one. There's also more sophisticated tools like proxies that we use a lot. For this example, that is something very, very simple. I'm just going to use everything that comes inside Kali Linux without knowing a lot of information security skills. So something that we can think is that every application has an admin, a root, an administrator, super user account, that if we start to thinking, there might be 5, 6, 7 usernames that has all the numbers in the lottery of usernames for being the user, the super admin account. Okay, so I'm going to try with admin, any password, I don't care. Okay, we see here the the communication between the browser and the server. And now I'm going to configure Hydra to try to test this test I did automatically for all the passwords that are inside this Rocky list. So I'm going Hydra here. My target is this server. The port for HTTP, in this case, this is not HTTPS, it's something local. It's 80. The protocol that I'm going to use is HTTP form, HTTP post form. For making more verbose to understand what is going on, I'm going just to click here, show attempts. So every password that is being tested is going to be printed. I'm going to tell that the username that I'm going to use is admin. I can add a list here and let it run with, for instance, admin root. In this case, if the domain is victim, the name victim, if using the name of the organization, this kind of stuff. As a password, I'm going to use the password list. The password list I'm going to use is this one called Rocky, that it comes building in Kali Linux. Okay. Now, what I have to do is to tell Hydra to understand when the attack was successful and when it fails. In this particular example, the navigator is doing a post to login. Copy paste. To login, and we can see that is sending a username and a password. So what I have to do here is to say, okay, send it to the login URL with the username. This means replace it with the username you have been prompted before. In this case is admin, and the password that comes from the word list. And the last thing that I have to do is to tell Hydra how to know when it fails. In this case, when it fails, it gets this red alert saying try again. So I'm going to use the word again. Okay, if the response has not the again word, it means it works. So now I'm going to tell it to start. And as you can see, a lot of passwords attempts start rising here. This could take a little time, but as I told you before, something that gives has its time. So you just can leave something like this running with your favorite word list, do something else, start preparing your next attack or whatever. And after a minute or so, we may have good news for us as attacker. A skilled attacker will not use this. A skilled attacker will use other kind of tools, like for instance, Bear Proxy or WhatsApp or some Python scripts to do this from different locations at the same time, for instance. Well, we have here a winner. The password in this case is Winnie the Pooh. So admin Winnie the Pooh, login. You see there, that was the password. And we log into the application. So coming back to the OWASP model, what happened here? We have a threat agent, somebody is doing, it's a threat for our organization, in this case, a script kid, which has an attack vector. It's attacking our application in a particular way. In this case, it's using a dictionary attack against the login application. The security weakness here is that the attacker can do a lot of logins without any kind of anti-automation mechanism. In this case, there's no control at all. Sometimes what you can see is that an account is being logged after 10 attempts. And there's a time log that if you miss the password 10 times, you get a 2 minutes ban. Sometimes you get a CAPTCHA that force you to put the CAPTCHA every time, and that kind of things make this kind of attack pretty practically impossible. Okay, and in this case, there's no CAPTCHA, there's no security control at all. Okay, so there's no CAPTCHA, no user blocking policy, nothing. The attacker can do a lot of attempts, and if it is lucky, it could get in. And the technical impact is that we have a vulnerability, we have a issue on our login page. Okay, but the important thing is the business impact, because the attacker abusing this functionality, finding an issue here, actually for the business, it means that the attacker can do whatever function the legitimate use can use. In this example, it can see, for instance, invoices. Okay, so that was the first part of the attack. We get into the application, and as I told you, we have here a new feature that is called invoices. If I do search here, I find an invoice. Okay, it works as expected. Okay, there's another kind of attack that an attacker mostly uses a lot of times, that is called SQL injection. A SQL injection is an attack that consists on making the application confused between user input and SQL sentences. In this way, let's suppose that we have a SQL sentence in our application. For instance, that one there. And what we expect is that in the owner variable, we have the owner name or the owner ID, and in the name variable, we expect to have the item name or something like that. But what if the users adds, the attacker uses Wiley as owner, and for the name variable uses something like that? In particular, this string here is one of the most basic SQL attacks that can be done. As a result, what we have here is a SQL sentence that is completely valid because, as you see, the commas are completely well formed, the sentence, and the meaning of the sentence has changed dramatically. Now it's not going to just send back the records where the owner is Wiley and the data name is name, because that's true or A equals A, which is always true. So this query is going to return all the records from the item table. Okay. And also using techniques particular crafted for this kind of attack, an attacker can get all the database completely from this attack. It doesn't matter the table, it doesn't matter the characteristic of the SQL injection. If there is a SQL injection, it's pretty much a fact that the attacker can get all the database from that particular vulnerability. For doing that, you may have a lot of skills in SQL and injections, or you can use well-known software called SQL Map that can automate a lot of the work for you. So let's see it working. I have here an URL, and me as a scripty kid, I have this URL. I have entered here. I don't know much about the tool, about the application. I'm just here because I could be here. So what I'm going to use now is the tool called SQL Map. Okay. I'm going to use SQL Map this way. I'm going to tell SQL Map okay. I'm going to tell it, well, I have this URL here, okay? I don't know how, but if you see a SQL injection, dump all the data that you can. Go to all the tables, to all the databases, and get all the information that you can. If you have any questions, I'm not the guy. Just you make the decisions. Do the decisions that a regular attacker does. And what we need here is to add, because this page is authenticated, we have go through a login to tell SQL Map that is already logged in. What I need is the value of the query of the cookie for the session. I pick it from here and I tell it the session that you have to use is this one here. And after this, and I repeat, you can see this in a lot of forums, in a lot of posts. There's videos about this. You just let SQL Map to do its work, and after a few minutes or less, we may have some pretty nice results. Okay, in this case, it has seen that there's a SQL injection in the description parameter. Doing this attack here, can see a lot of information. You can see here that do you want to crack? The response was yes. Do you want to store hashes? The response was no. All the decisions were done by SQL Map. Now SQL Map is trying to crack the password of the database because it already get the information of the password of the database. I'm not going to do it right now, so I'm just going to quit that. And after getting all the sentences that it needs, we see here that we have the information for the invoices, okay. we have the information for the users. This is interesting because we already know that we have an admin, which password was Winnie the Pooh, but there's another user. That's pretty much interesting. And there's also another table that was not present in the application, that it was about credit cards. They were stored in a very ugly way. There's a design problem here, but there also, and also it could be also retrieved by SQL map without even knowing that table exists. So what it does was to query the metadata from the database, gather all the tables available, and for all those tables, they start doing select queries and getting all the information from the database. So after running this command, we get all the information from the database. Okay? There was a SQL injection there. And again, our attacker was not the most qualified attacker in the world. It was a scripty kid just doing things that can be learned from information sources that are available free and for all. Okay. So what it does was getting all the tables from the database. In this case, we have a scripty kid doing a SQL injection without knowing exactly where. Just tell the SQL map to test this application. And if it was successful, it was. If it was not, then not injectable. Okay, let's go for the next one. The security weakness was a text concatenation and SQL injection. This was an anti-pattern that was used in the programming of this application. It should have been used and stored prepare statement or the sanitize the input. Using prepare statement is the only well-known way of not getting this, but in this case, it wasn't used it wasn't programmed the right way. The technical impact was in the list invoices. The issue we found was in the list invoices function, but the business impact was the unrestricted view of all data on the data. In some cases, an attacker could inject data into the database, but this kind of attacks is used to retrieve data most of the time. Okay. Also, something that we have retrieved from the database was another username with something here. That seems to be that from this number here, hexadecimal number or string, whatever you want it to call, it's okay, it doesn't matter. This means Winnie the Pooh in some way. Okay, we can see that because we see it here. So this should mean something. Okay. And that is a hash. A hash is a common way to store passwords without storing it in plain text. We have seen a lot of systems using hashes for storing passwords. That's a good idea, but it's not a 21st century idea. It's getting older, and then that has a lot of flaws. There are much better ways of doing this with using hashes and other things, but in particular, hashes has one property, is that if you apply a hash function like SHA-1 to a string, a byte array, or whatever you are applying it to, you always get a fixed length string. Okay, and if you put here the same input, you always get the same output. So for testing passwords, what some people do is to hash the password, store the hash, and if when the user inputs the password, and the hash function is applied to that password, if it matches with the one that I already know, it means that your password is correct. So there's a false sensation of being safe for not storing password in clear text. Okay. It has a few drawbacks. If you see it here, something that attackers do is to get a lot of well-known words or word list or information. They apply this function. And they store the name, the number product of the function. So if they see any kind of hashes, they start comparing with the hashes they already know. Okay, for this to avoid this, in your systems, you have to at least use a safe function like SHA-266 and use a salt to make this calculation a little harder. In this case, what we have seen is that we have a hash here. So we can try to do the reverse operation of hashing, which most of the time is called cracking. So instead of trying to do it with a tool like Sean the Ripper or Hashcat, I'm going to Google for that hash. Okay, and one of the best sites for doing this kind of cracking is CrackStation. In this site, we can paste our hash, and we try to ask CrackStation if they already know the text that matches with that hash. In this case, it was already stored in this site, and this is the password behind that hash, which was of type SHA-1. Something nice of this from this site is that if you don't know the type of hash, you paste it here and you just can try what happens, because it supports a lot of different hashes. So now, having password, what I can do is to try to see if it works. I'm going to paste the password here. And to paste the username here, and it works. Okay, so we successfully reversed that hash to a working password. Okay. You can use CrackStation, or if CrackStation is not successful, you can try offline tools like Hashcat and Sean the Ripper. And you can try, if you have the right hardware, like a GPU, and you can try 5 million passwords per second. So you can make a lot of rules to start looking for words, start looking for information about that person, and try to start thinking in a million of passwords. For instance, the name of the person, the year, and hashtag, capital case, the name, and you can do a lot of permutations and changes from word list, and you can test a lot of hashes. There's a lot of information about how to cracking, and there's a specific kind of hacker that is called cracker, that it uses all its time to crack these hashes to the pre-images of those hashes. Okay, so now we get into the application. We get all the data from the application. We get another username and password. What can we do with that information? Remember, the methodology is that when we get some information, we try to look in what other door can be open now. Okay, and the attackers, most of the time, if they are opportunistic or cryptic, it doesn't really care which door they're trying to open. They're just trying to open doors. So if we have an email and we have a password, What may have happened? Any ideas? We have an email here from the victim, our victim. So
It could be the same password for any other website.
exactly, and that happens a lot. And sometimes you wonder why your Instagram was hacked. Instagram was hacked. No, maybe you reuse that password in another site that hacked, or you put a password in another place and that place was a malicious site. So the attackers do a lot of this. This happened to LinkedIn in 2012. Attackers get a lot of passwords and they try to reuse those passwords in emails. Sorry, in emails, in websites, and some attackers get a lot of money sending emails saying that we have all your information, we log into your email, this is some proof of information. If you don't send us some amount in Bitcoins, we are going to publish all the information to your family, friends, and you will be a public shame. Most of the times that's just a scam, sometimes it's not. So what I'm going to do now is to test that email with the password we get from CrackStation. And if we are a little lucky, we get into Gmail. After an attacker gets into here, what it does is to, of course, look for emails, and something that an attacker can do when it has access to a mail is that they can try to get information about other accounts. For instance, in this case, Twitter. This user has a Twitter. And also it can log into the Google Drive. We have three folders here: work, school. Work may be interested, but there's something called private here. And this particular user has a document with passwords. Okay, we have seen this a lot. And after seeing that this user has a Twitter, something that the attacker can do is try to log into Twitter. I already have an account. I'm going to log in user phone, email, or username. So what I'm going to use is it's not my email, it's his email. I can try the password here. It's not going to work. I already know that. But something that attackers do a lot is this. I have access to the email. So now what I'm going to do is I'm going to say, okay, I forgot my password. Okay, so I'm going to enter my email. I'm going to tell it, okay, yes, send me an email. So that email, it's here. I get the token. I'm going to create a new password here. Oh, I just forgot it. And this is the way an attacker can get into your account. So what happened here is that from a security breach on a particular site, the user reuses that password from one site to another, and from that that reuse of the password, we get into the email, and from the email, we get into Twitter. Okay, so an attacker do this kind of deductions. Okay, a lot of people do bad practices with the passwords. If we get password from one side, when we try to use it in other places. And now the fashion today is to hack Instagram. I don't know why, but there's a lot of people getting Instagram hacked, and most of the time is because that password was compromised from a breach, from a security breach, some elsewhere, and the person is getting harmed because a security issue in some other site that may have used a long time ago. And of course, people that use passwords are getting into a very difficult time for this kind of attacks. Okay. Other common attacks. Something important is that everything that I have shown you today are very basics. It's the ABC from hacking, from a security application security or software security perspective. But these are basic things, but we still see a lot of this in a lot of software. We are far too away from getting all the easy stuff outside the world. Now we still see a lot of these things. There's another common vectors that I have not covered today, but we see it a lot in the wild. That is software with known vulnerabilities. Is using old software that has known issues, as somebody has published a vulnerability, the vendor has fixed it, and the patch has not been applied, is getting you into risk, because old software has a very big chance of having vulnerabilities. There's also that we have seen a lot of hidden exposure layers. When I say hidden, they're not hidden at all. But for instance, if you are developing an Angular application or React application, you are for sure using an API. Okay, that API can be very easily abused if it was not properly think. Tokens are the very basic thing for getting into the API, but we have seen a lot of information that should not be there, a lot of features that should not be published or not be able to be used with the same token. And there's a lot of things, a lot of information being leaked using APIs nowadays. Cross-site scripting is when an attacker can craft an input and make your page change completely from putting you a picture there, from passing completely unnoticed and stealing your information and sending it to another server. And safe configuration, it means you have a safe software, but you put your software and you don't do all the hardening for the stack, for the technology stack or for the application itself. And as a result, you may have a username with a default password. You may have forgot to change from developer mode to production, stuff like that. Security through obscurity. There's some, if you think that your application can be hacked because nobody knows how it works, you are using security through obscurity. The problem with that is that people can't, it happens two things. Attackers are very good guessing things. Okay, they have seen a lot of software, so they are good guessing how it should be done, or what the developer may have done with that. And the other thing is that secrets are very, a lot of people changes from work to work, and they sometimes comment. People may be fired or whatever. So secrets are for the short term. In the medium term, that secret is going to be leaked to somebody else, and that could be harmful for the organization. And last but not least, design failures. If you don't design the applications having security in mind, it's probable that you may doing something wrong, and it's going to take a lot of time and a lot of effort to fix it. it's way much better to think on security from the very beginning instead of thinking of security while you are contracting unethical hacking, if you are contracting unethical hacking. Well, conclusions. There are different types of hackers with different skill sets. Even the less skilled hackers could follow a tutorial, and that tutorial could lead in some kind of threat for us. So we better see those tutorials and try to do those things before. Sometimes if you see something and you think in one of the applications you are developing, it makes sense, you maybe I advise you to try to do it by yourself before somebody else does it. And it's crucial to detect vulnerabilities, but not only to detect. Sometimes in the software security industry, we talk about ethical hacking and breaking things and how horrible is everything, okay? That's to detect, but it's very important to fix them. It happens it could pass 2 months from the disclosure to the fix. And in that time, we are vulnerable, okay? And it's important to create culture in organizations that vulnerabilities should be detected and fixed. Sometimes it's not an easy job. Okay. Well, thank you for your time. This was everything for today. If you have any questions, Santosh or Che Prado.
Gerardo, thank you so much. This is Sergio.
Okay, Sergio.
How are you? Thank you very much. I enjoyed your presentation a lot, and I learned something, which is always great. So I don't know if anybody in the group wants to actually raise their hand and ask a question. Anybody has a comment regarding what Gerardo just talked about? Maybe you had your own security vulnerability happen to your company and you want to share what happened or how it could have been avoided. And no questions. Okay.
Okay, I have a question.
Yeah.
Hi, my name is Hemant. Actually, recently I was one of my laptops got attacked by a ransomware. So it encrypted all of that data, and that was, I guess, IQQW. So it encrypted into that format. Like my color, like my file name changes from, let's say, color shade dot pdf dot IQQW. So that was a thing which actually affected my laptop, and all of the data got encrypted. Yet C drive was not harmed, I guess, because of the running function. They wanted people to see their message. So in the Word files, they have placed like, okay, we can decrypt all your files. Just you have to pay $450. So it was like that. But to overcome that, that laptop didn't have that antivirus. So what I did was, firstly, whenever I used to restart the laptop, it used it to run exe file for encrypting all the files. So I just from my phone just click the picture of that. It shows the directory of that file, and then when I relog in, I deleted those files and all the files associated with it, going through Task Manager. After that, I knew that okay, my laptop was free from that ransomware now. But to make sure, I installed the antivirus, and yeah, it detected the same. But the only issue after that was that the files were not decrypted. So that was one of the issues which I faced. Have it been that I used the antivirus, then probably that antivirus would have decrypted those files too. But as I removed that, I was that antivirus didn't recognize those files as being encrypted, so it never decrypted them.
No,
So it's like that now.
the antivirus can decrypt that information. Unfortunately, the best way to avoid a ransom is to have backups, because after a laptop is compromised with a ransomware, we did this in our laboratory. We get a ransomware from a friend of us that was attacked by a ransomware, and we put that ransomware in a Windows computer, okay, with information, with for instance usernames, password stored on the browser on Chrome, and everything was fake. Okay, we did a lot of simulation there. There was not our users. There was another account that was not used by anybody. And after we run the ransomware, the next day the Instagram account was completely changed for somebody else. They do a takeover from the. So my recommendation is format the laptop, start from scratch, and I hope you have backups, and change all the passwords you have ever used in that laptop, because all those passwords are compromised, and don't ever use them again.
Yeah, I did that. The Instagram ID was changed and it started following people. So I had to take that control back, change the password of it. And I guess many of them have been compromised. But yeah, that is there. So those files which are with me now, I can decrypt them. So by renaming them, I can decrypt. But it's very much difficult to decrypt them like one by one. So is there any tool by which I can decrypt and rename all those files? So they are not encrypted anymore by just renaming and removing that IQQW dot at the end of that file name. They are all, they can be worked with. But changing about thousands of files and renaming them, it's something which is impossible.
No, what I will do is to make a Python script to start going through all the folders, and every time it sees a file with that extension, to rename it to the file without the extension. I think that a Python script will do the job.
But to be very honest, I don't have coding skills.
Okay.
I can make algorithms, I can strategize things, but I'm not a coder.
So something like that, you might be able to figure it out just by cutting and pasting code from the internet. But you're going to need to have some code to go recursively
that will require at least 4 to 5 hours of research, and that maybe after that it works, it doesn't work. So I was just wanted to know if anybody can help me out and provide that Python script or any code related to that.
Post it on the meetup, on the conversation on the meetup. Maybe someone has done that already and they can help you.
Are you running Windows, right?
But post it on the comments in the meetup, and I'm sure that someone will help you from there.
Okay.
You know, like on the what's it called? The discussion section. That's what it's called on the meetup. Go to the meetup and then go to the discussion and post there. And I'm sure someone will be able to help you if it's just renaming the files. There's probably going to be a way to do it.
Okay.
So I'm just going to close this session unless someone has another question. And I do want to encourage whoever is listening to share if you have any interest that you want us to do the next conference. You know, any topic that you want for the next conference. I'm looking for ideas so that we can keep this, you know, this group forward. You can move it forward and have everybody learning. We're going to try to do soon the next one, maybe instead of a webinar, do it in person. I don't know. I think we're well, personally, I think from the coronavirus point of view, we're ready for that. We just have to find a location and see how people feel. I don't know. I feel okay with in person now, but maybe other people don't. So I don't know. I don't want to get into that conversation right now. But if you guys think that it's better to be in person at this point, and you want to share that on the meetup, and as I said, any topics that you feel like are interesting, you know, unrelated to the, of course, programming and all that stuff. So if nobody else has any other questions, I say we say goodbye, and everybody have a great day.
Very much.
Thank you, Gerardo, and bye everyone.
It was a
Thank you.
pleasure. Bye bye.